Jai Hind children, welcome to today's class. The chapter sets, so far we have discussed about what about the sets, then types of representation of the set, that is in a roster form as well as in set builder form. Then about the various types of sets such as empty set, infinite set, finite set, etc. And in the last class we have studied about the subsets. Today we are going to start the continuation of subsets as subset of real numbers. You know that real numbers can be represented with the letter capital R. The real numbers can be divided or classified as rational numbers and irrational numbers. Rationals and irrationals. Rationals are usually represented with the letter Q and irrationals are represented with the letter T. Remember that. Rationals are represented with the letter Q and irrationals are represented with the letter T. Now, you know that what are rationals? Numbers of the form P by Q, that is 2 by 3, minus 17 by 12, such numbers, etc. Minus 17 by 12, etc. These are examples of rational numbers. That is numbers of the form P by Q. But irrational means numbers of the form root 2, root 3, pi, etc. which are non-terminating and non-recurring. So means that rationals and irrationals are part of real numbers. But among the rationals, you can see one more set of numbers as integers. Integers means negative integers minus 3, minus 2, etc. Then positive integers 1, 2, 3, etc. These are integers. Integers are usually represented with the letter Z. So, within the rationals, you can see integers, or you can say that integers is a part of rationals. Now, among the integers, if you take the positive integers 1, 2, 3, etc. along with the 0, you can name it as whole numbers. This also is studied in lower classes, whole numbers. So, whole numbers is actually a part of integers. Whole numbers are usually represented with the letter W. And now, among the whole numbers, if you take the numbers 1, 2, 3, etc., an infinite collection of positive numbers, you can call them as natural numbers. Natural numbers. Natural numbers are usually represented with the letter N. Thus, you can say that a natural numbers is a part of whole numbers is a part of integers is a part of rationals, and the rationals are part of real numbers. So, we can say that Q and T are subsets of the real number R, and Z is a subset of Q, W is a subset of Z, and N is a subset of W. From this, we can write like this. N is actually a subset of, that is the set of natural numbers, is a subset of the set of whole numbers W, and W is a subset of the set of integers Z, and Z is a subset of the set of rationals. Again, you can say that the rationals is a subset of reals, and irrationals also subset of the real numbers. So, is a part of, we studied in last class that is a part of, that can be represented as subset. Subset is usually represented with a symbol like this. Thus, if we consider the set of real numbers, we can say that Q and T are separate subsets of R, Z is contained in Q, or Z is a subset of Q, W is a subset of Z, and N is a subset of W. Hope you understand this. Now we can study what happens when intervals comes as subsets of R. Let us consider the number line R, in which the condition given is that I am going to take two elements A and B in this number line. Let A and B be the elements in this number line with A less than B. So pictorially I am going to represent like this: A and B be the elements in this number line with A less than B. Here I am going to define four types of intervals. Types of intervals I am going to define. Types of intervals. Type 1 is that intervals of the form the set of all x such that A less than x less than B. We study this as the set builder form. I am going to represent this set in the number line. The number line R, which what is given for you? A is less than B. A is less than B. Here, from this part you can say that from x less than B, from this part you can say that the value of x lies here, and from this part you can say that the value of x lies above A. Thus, all the elements between A and B are included in this interval, but the condition is that a less than symbol represents that the point A is not included. That we can mark with a hollow circle, and the point B is also not included. That we can mark with a hollow circle here. So, the area or the region between A and B in which A and B are not included in the interval or the set as the less than symbol is mentioned. Such intervals are called as open intervals. Such intervals are called as open intervals. Open intervals are represented with the symbol like this, open interval. In this case, I am going to represent the given interval as open interval A, B. Means that the endpoints A and B are not included in the set. Type 2. If the set is given in the format, the set of all x such that A less than or equal to x less than or equal to B. Again, I am going to represent this in the number line with the number line R, in which A and B are given with the A less than B. From this part you can say that x is less than B, and from this part you can say that x is greater than A. Thus, all the points between A and B are included in the set, but the condition is that a less than or equal to symbol means that the point A is included, that I can mark with a darkened circle, and on the right side the point B is also included as less than or equal to symbol mentioned here. So this part also I can mark with a darkened circle. So actually this is the representation of a closed interval. Such intervals are called as closed intervals. Closed intervals are usually represented with a symbol like this. This is the symbol for closed interval. So what a closed interval means? The value of x lies between A and B, but both the endpoints A and B are included in the set as less than or equal to symbol is mentioned. Such intervals are called as closed interval. In this case, I am going to mark the given set as closed interval AB like this. So, if the less than or equal to symbol is mentioned, you need to mark closed interval with the square brackets like this. Now, I am going to define type 3. Type 3. Type 3 means the set of all x such that A less than x but less than or equal to b. This is the third type. Again, I am going to represent it in the number line with this number line R, in which the condition given for you is A is less than B. A less than B. From this part, you can say that X is less than B, and from this part, you can say that X is greater than A. Thus, all the elements between A and B are included in the set. But the condition is that here a less than symbol represents that the point A is not included, that we can mark with a hollow circle, but the point B is included, that we can mark with the darkened circle. So this is the representation of a interval which is called as, such intervals are called as semi-open, or can be called as semi-closed. Semi-closed, both are same, semi-open or semi-closed intervals. The usual representations are like this: either open on the left side and closed on the right side, or closed on the left side and open on the right side. Thus, what represents the semi-closed intervals? The set of all x which lies between A and B, in which the endpoint A is not included, but the endpoint B is included in the set. Here, I can represent the given interval like this: closed at the, not closed, the open. Open at the point A, but closed at the point B. This is the given representation. Now, I can discuss with a type 4. Fourth type of intervals. Fourth type of intervals means that the set of all x that A is less than or equal to x, but less than B. Again, on the number line, I can represent the given set like this, number line R, which A and B are the points in the set with A is less than B. From the given condition, or from this part, you can say that x is less than B, and from this part, you can say that x is greater than A. But the less than or equal to symbol mentioned here means that the point A is included in the set, that you need to represent with a darkened circle, and the point B is not included in the set, that we can represent with a hollow circle. So, all the points which lies between A and B, in which A is included and B is excluded, this also can be called as a semi-open or a semi-closed interval. Semi-open or semi-closed interval. In this case, I can represent the given set as, what about on the left side? The left side it is closed. So, the closed interval A on the left side, but it is open on the right side. So, closed open AB. This is the representation for the last type of set, closed open AB. Now, we are going to study a new term, length of the interval. The number B minus A is called the length of any of the intervals: open interval AB, closed interval AB, open closed interval AB, closed open interval AB. Whatever be the type of interval, its length can be found out by using the number B minus A. For example, consider the interval closed interval 3, 7. Another interval open interval 3, 7. Third interval closed open interval 3, 7. Whatever be the length of the interval, whatever be the type of the interval, its length can be found out by using the formula: the length of the interval equal to B minus A. If the interval is AB form, B minus A means the larger number 7 minus 3, which is 4. Here also, the length of the interval is the larger number 7 minus the smaller number 3, 7 minus 3, which is 4. That is, if the interval is of the form AB, the second number represents B, the first number represents A. Here also, the interval length can be found out by means of the formula B minus A, which is 7 minus 3, which is 4. So, whatever be the type of the interval, its length can be found out by means of the formula B minus A. Let us discuss some problems. First question: Write the following as intervals. Sub question 1. Set of all x that x element of r minus 5 less than x less than or equal to 6. You are asked to write this set builder form into intervals. You know that how to write it as interval, which implies minus 5, 6. The interval comes between minus 5 and 6. All the elements between minus 5 and 6. But the condition is that minus 5 is not included. So it is open. Minus 5 is not included. This is a less than symbol. And plus 6 is included. So you have to mark as plus 6 as closed interval. So the interval is minus 5, 6. The second question is set for x element of r such that 5 less than or equal to x less than or equal to 6. This you need to represent as both the sides are less than or equal to. You need to convert that to interval. So it can be written as closed interval 5, 6 as less than or equal to symbol is enclosed in the set. Come with the second question. Write the following as intervals and also represent on the number line. First question. Set of all x element of r such that 2 less than or equal to x less than or less than 8. You know how to write it as interval. The corresponding interval is from the element 2 to the element 8. All the elements lies between 2 and 8 you need to consider, but 2 is included and 8 is not included. So it can be represented as close the open interval to it. But you are asked to represent it in set number line also. How to represent it in number line? Draw a line which represents numbers 2 and 8. But here the condition is that 2 is included but 8 is not included. 2 you need to include. So darken the part 2 but 8 not included. So put a hollow circle there and need to shade or darken this portion. Actually, this portion represents a 2, 8. Come with the second question. Set of all x that x element of r and 5 less than or equal to x less than or equal to 6. At first, we can write it in the form of interval. The corresponding interval is both sides are closed. So, closed interval 5, 6. This is the interval corresponding to it. But for to represent it on the number line, you need to draw a number line which represents the numbers 5 and 6. But both 5 and 6 are included as there is a less than or equal to symbol. So you need to darken the circle and shade or darken the region in between them. So this is the representation of this set on the or interval on the number line. Okay, universal set. Through an example, I will give you an idea about the universal set. Consider a set as set A equal to the set of all x set that x is a student of class 11A. X is a student of class 11A. And I am going to consider another set B as B is equal to set of all x set that x is a student of class 11B. Class 11B. And another set C as the set of all x that x is a student of class 11C. Here 3 sets I consider. I am going to consider another set which is suitable to contain all the above sets A, B and C. That I am going to consider here as set of all x that x is a student of class 11. Definite that this set can enclose the sets A, B and C. Why? Because any student of class 11 can be either in 11A or in 11B or 11C, or 11A, 11B, 11C, that is set A, set B and set C are part of this set. This set I am going to consider as the universal set represented as U. Universal set is usually represented with a U, capital U. So, U means that the set of all x that x is a student of class 11A. From the above example, you can say that A is a subset of the universal set B is also a part of this universal set U, and C is also a part of this universal set U. So, universal set means that a superset which can contain all the subsets under our consideration. Consider another example. Another example 2 I am going to consider. Consider a line segment AB. A line segment AB in which I am going to represent 2 points P and Q. Now, 3 sets are under my consideration. One is set A. Set A equals the set of all x such that x is a point in the line segment AP. X is a point in the line segment AP. And another set B as set of all x such that x is a point in the line segment PQ. That is, this much elements represent the set B. And another set C as set of all x such that x is a point in the line segment QB. This part I am going to consider as the third set. Now, can you say a set which is a superset for all the above sets? I am going to consider a set as the set of all x such that x is a point in the line segment AB. Definite that this x is a point in the line segment AB, or this set U is actually a superset for the sets A, B and C under our consideration. Or you can say that the set A is this much is A is a subset of the universal set. This represents B, the set of all elements in PQ. This represents B and this represents C. All these sets are subsets of our universal set which consists of all elements in AB. So clearly here also you can say that clearly the set A is a subset of the universal set. B is also a subset of the universal set. C is also a subset of the universal set. So from this you can conclude that what is a universal set? A set which can be a superset for all the sets under our consideration is called the universal set. Now come with the new section, power set. The collection of all subsets of the given set A is called its power set, denoted by P of A. The collection of all subsets of the given set is called power set. Power set is usually denoted by P of A. At first we can check it, then come to the note. Through an example, I will give you the definition of power set. Example, consider a set. Consider the set A equal to the set 1, 2. What are the possible subsets you can form from this? Already told you that if you are asked to take none from this, you need to consider the empty set. If you are asked to take only one at a time, then you need to take the sets set 1 and set 2. If you are asked to take 2 at a time, then 1 and 2 can be taken. So, the possible collection is either you can take the empty set or the null set. The second is only one at a time means that the set 1 as well as 2 you can take. 2 at a time means that the set 1, 2. So, these are the possible collection of sets you can form from the given set A equal to 1, 2. Now, I am going to write the power set. Therefore, power set is usually denoted by the letter P of A. Power set of A equal to the collection of, so you need to put a braces. The collection of which are the possible subsets? The null set, the set 1, the set 2 and the set 1, 2. These are the possible subsets we can form from the given set. Now come to the note. If a set A has n elements, then its power set P of A has 2 raised to n elements. Now, can you say what about, again come to the given set, given that A equal to 1, 2. Can you say how many number of elements are there in the set A, or what is the cardinal number of A? 2 elements, 1, 2. What is the cardinal number of the power set of A? Power set of A contains how many elements? 1, 2, 3, 4. 4 means that which is equal to 2 raised to, what is the n here? 2. 2 raised to 2. So, when the set has 2 elements, the power set has 2 raised to 2 elements. Consider another example, example 2. Consider another set. Consider the set A equal to the set 1, 2, 3 or A, B, C. At another set I am going to consider. If you are asked to take the possible collection, if you are asked to take a none from this set, then the only possibility is taking of the null set. If you are asked to take one at a time, then you can take either A or B or the set C. 3 sets are possible. If you are asked to take 2 at a time, the possible collections are either AB or BC or can take AC. If you are asked to take 3 at a time, then the possible collection is ABC. Now I need to write like this. If you can directly write as. Now I am going to write the power set. Therefore, the power set is usually denoted with the letter P of A. P of A equals, the collection consists of, the first one is the null set, the second one is the set A, set B, set C, singleton sets, singleton set A, singleton set B and singleton set C. Then taking 2 at a time, the set AB, then the set BC, then the set AC, and the last one the set ABC. These are the possible collection of subsets which can form from the given set. Now, how many elements are there in the given set A, or what is the here the cardinal number of the set A, n of A equal to how many elements are there in the given set? 1, 2, 3, 3 elements. How many elements are there in the power set of A? Power set of A, what is the cardinal number of the power set of A? We can check 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there in the power set of A. This 8 means 2 raised to 3. What is this 3? 3 is actually the cardinal number of the set A. Thus, in general, so if the set A has 2 elements, then the power set has 2 raised to 2 elements. If the set A has 3 elements, the power set has 2 raised to 3 elements. Or in general, if a set A has n elements, then the power set P of A has 2 raised to n elements. A very important statement. An MCQ question can be asked from this section too. That's if the cardinal number of A equal to n, then the power set of A has the cardinal number of the power set of A equal to 2 raised to n elements. If a set A has 100 elements, then the power set of A has 2 raised to 100 elements. Very important. Now my question is that write as a note. How many elements? Very important. How many elements has power set of A if A equal to the null set? Very important note. Even though I give you as a question to you, remember it is a very important point. Note. How many elements has the power set of A if A equal to null set? Okay, we can check A equal to null set. Means the number of elements in the set A or the cardinal number of A equal to 0. No elements are there in the set A. Now we can see what about the number of elements in the power set of A. If A has no elements, the number of elements in the power set of A is 2 raised to the cardinal number of A 0. What is 2 raised to 0? 1. So the cardinal number has, or the power set has, only one element. Can you say what is that element? The power set of A equal to the collection of all possible subsets you can form. If the set A has no elements, or if the set A is a null set, then the possible subset you can form from here is only the null set. So the n of the power set of A equal to 1. I hope you understand this. Now note down the homework questions.